Welcome all of you to another video of Maths Made Easy. Okay, so today we are going to take up one 8th standard topic in rational numbers. Okay, 8th standard, this is the first chapter in 8th standard, rational numbers. And as I said, I shall be going serially. I am doing the sums from R S Agarwal today. That is, serially I am doing them. So this is from the first exercise that I am taking up today. And I shall be moving serially with all my videos, one after the other, from R S Agarwal now. Okay, so this is rational numbers that I am taking up today. Okay, so what are rational numbers? Okay, what are rational numbers? Now if we talk about rational numbers, we can talk about, let's see, numbers which take the form p by q are rational numbers. Okay, numbers which take the form p by q are rational numbers, where p is an integer. I'm sure this definition is told in your school also. Q is also an integer and q is not equal to 0. Now what are integers? If I take 0 here, 1, 2, 3, 4, 5 and so on, it goes minus 1, minus 2, minus 3 and so on, it goes here. Okay, so here 1, 2, 3, 4, 5, minus 1, minus 2, minus 3 and it goes on this side. So these are integers. So here also we want an integer, here also. Remember, 0 is also an integer. Q is also an integer. But then there is some restriction. Q cannot be equal to 0. So here they allow a 0, but here they don't allow a 0. Okay. So here I can take any number including 0, not here. Okay. So let me take the numbers then. Let's take, now if I take 2 by 3. 2 is an integer, 3 is also an integer. Therefore, this is a rational number. If I take minus 2 by 3, then also minus 2 is an integer, 3 is also an integer, so it is a rational number. If I take 1 by 3, yes, this is an integer, this is also an integer, so it's a rational number. If I take 3 only, if I take only 3, okay, then if I take only 3, then it is a rational number or not? Yes, it is a rational number once again. Why is it a rational number? Because I can always write like this. I can write a 5 or I can write 5 by 1. So just a number, even I can write 235. That is also a rational number because I can write 235 by 1. That is perfect. Okay. So that these are all rational numbers. Now if I write 0 by 3. This is also a rational number because 0 is allowed in the numerator, not the denominator. But if I write 3 by 0, this is not a rational number because of this condition. Okay, so this is what are rational numbers. Now this is not the only definition of rational numbers. There is something else that I want to tell. Now here you are noting that we are taking positive fractions, negative fractions, we are even taking whole numbers, we are even taking 0. Everything is allowed in rational numbers. Okay, so why, when I take this positive fractions, when I take the negative fractions, then you might feel, okay, fractions, after all fractions. Okay, we have done so much of fractions since 4th standard we are doing fractions. Okay, so why is it a separate chapter now? Now if you see that when you were in 4th, you had done something like this. You had done, this is 1/4 of a cake, shade 1/4 of the cake. You have done, right? Okay. So if I do, this is 3/4 of a cake. And then you did lots of problem sums on this. Okay. So, so and so I had a ribbon and cut out 3/4 of it and then how much is left and something like that. So did you ever get a sum where you were asked to add minus 3/4 of a cake or 7 by 15 of something, minus 7 by 15 of something? Did you face it? Now you are reminded, okay? Because you never thought of this, you didn't notice it because you were busy doing fractions, okay? But then if this is, we never talked about negative fractions earlier. We only talked about positive fractions. We did subtract. But then we never subtracted negative fractions. We only subtracted positive fractions. Right. Now this is the chapter where negative fractions will also come. Okay. So sometimes when we add and subtract, you might feel they are just like fractions. But then you never subtracted a negative fraction from a negative fraction. like that. Okay, so what happens here is, in this chapter you will see that we are this was the number line and 0, and earlier it was only half, and it was only 1.5, and then it was something the 3/4 over here, okay, or maybe 2.5 over here. So you worked like this earlier. We were only in this part of the number line. Now we are also in this part of the number line. Okay, we are also in this part of the number line. So this is -1, -2, and this is -1.5. So this time, sorry, this is -1/2. Okay, so now we are going to consider positive fractions also, negative fractions also, and whole numbers also. Okay, so that is what is rational numbers all about. Okay, express -3/5 as a rational number with denominator, as a rational number with denominator 20. There are 4 sums here. -30, there's the first question of the first exercise, 35 and -40. Okay, so these are the 4 things. These are the 4 denominators. We have to convert this fraction having these denominators. Let's see how we do it. -3/5. Yeah. Now one thing here is this minus sign, I want to talk about that also, can easily be brought and written like this, no problem. It's the same. Many people have doubt. Ma'am, it's written -3/5. Can we write it as 3 by -5? Yeah. So yes, you can write. You know what's the logic behind it? The logic behind it is very simple. You are multiplying with a -1 up and down. This becomes a plus, this becomes a minus. That's all. So instead of doing this small step, we straight away bring the minus down. That is the logic behind keeping the minus in the numerator or the denominator. What you can't do is, you can't do this. You can't add another minus sign. Of course, you can shift this minus sign above, below, but you can't get another minus sign in the fraction. Okay, so this is important. Okay, now with this concept, we will do these sums, which is -3/5, and we have to make the denominator 20. So if we multiply with a 4 here, we'll get a 20. But the thing is, that does make it a 20, but then that changes the fraction to -3/20. Yes, it changes the fraction to -3/20, which is not our sum. Our sum is -3/5. Both are different numbers. So we can't do it. So what we have to do? We have to multiply with a 4 here also. Means now we are getting an equivalent fraction. Equivalent fraction simply means that if we start reducing, we can come back to the original fraction. Then these fractions have, equivalent fractions always have the same value as the original fraction. So this is -12. Okay. So this is my sum. Okay. So I got -12/20, first answer. Let me take the second one, -3/5. Now I want the minus in the denominator, -5, 3, and this is into 6 because I want my -30, but -6 into 6 above and below. So that is 18 by -30. I got my answer. So here is one answer, here is another answer. Let me go for the next one. This is -3/5 into 7, because I don't have a minus in the denominator. So into 7, which is -21/35. Okay. So -21/35. Then -40. Okay. So -40 is -3. Sorry. Now I got that -3/5. I have to make this -40. So into 8 and into 8 now. Okay. So that gives me how much? That gives me -24/40. But that is what not what they want. They want the minus with the 40 in the denominator. So shift it. Okay, so here is my answer. Here are my 4 answers. Okay, how the same number with different denominators could be made. Okay, so now express minus 42 by 98 as a rational number with denominator 7. As a rational number with denominator 7. Okay, minus 42 by 98 as a rational number with denominator 7. Now here it is 98. We want denominator 7. Let's see what we can do. So let's see, minus 42 by 98. Let me cancel it by a 2. 21, this is 49, right? Okay. Now here I want the denominator to be 7. Now here if I want the denominator to be 7, I can do one thing. I can split this further, 7 into 7 minus 3 into 7. Yes. Now look here. This is the sum. How can I get the denominator 7? So if you are doing the sum correctly, you will definitely reach the answer easily. So after reducing, I am splitting them into factors, and now I can almost see the answer. See, 7 and 7 goes. So we are getting nothing but an equivalent fraction. This is nothing but a reverse of, what we did earlier. Earlier we started with minus 3 by 5, reached a number with a particular denominator. Here we are starting with a big number and reaching a number with a denominator 7. Okay, so here we will have to reduce. There we had to multiply. Here we have to reduce one common factor. Okay, similar question if they ask minus 48 by 60 as a rational number with denominator 5. Let's say they are asking with denominator 5. Okay, very similar question. So make this with denominator 5. First I will reduce it a little bit. So here I have minus 48 by 60. This I have to get with denominator 5. Okay, remember one thing, don't reduce with 5 only. Then your 5 will not be shown in the last step. So what we can do here is, here we can reduce first with a 2. 30, this is a 24. Now this is 6 into 4 is 24. I am again splitting, note it. And this is 6 into 5. Okay, we want a denominator 5. Be careful of the signs, don't miss them on the way, don't leave them behind. Okay, that happens. So this is minus 4 by 5. So this is how it can be done. Now there is something called a standard form. Standard form of rational numbers. Now what is standard form of rational numbers? Standard form of rational numbers are those numbers which, supposing I have, this is minus 12 by 30. Now this is not in the standard form. There are two conditions in standard form. Firstly, negative sign should be with the numerator. Okay, first condition. Second condition has to be it has to be reduced to the simplest form. What is reducing to the simplest form? So now I will cancel 6 2s are 6 5s are. I can't reduce it any further. So this is the standard form. Minus 2 by 5 is my standard form. Okay, so let me take another number and show you what standard form is all about. Okay, supposing I have 24 by minus 64. Yes, 24 by minus 64. This is 24 by minus 64. Now, how should I reduce it first? First with a 4 only. 4, 16, further with a 2 3s are, yeah, and 2 8s are. Okay, so it is 3 by minus 8, but then still not achieved. So 3 minus 3 by 8, that is my standard form. Okay, so this is my standard form and I can't reduce it any further. Which is greater? Okay, we'll have to do which is greater. Now, in which is greater, we have minus 4 by 3 or minus 8 by 7. One question. Okay. Now, 3 by 8 or 0. Yeah. Or minus 3 by 4 or 1/4. Okay. Or minus 5 by 7 or minus 4 by 7. So I have 4 questions written on the board here. Firstly, this is 0 and this is 3 by 8, that too positive. So 0 naturally is smaller, and the whatever the fraction is, as long as it is positive, it is to the right of the number line. 0 is less, 3 by 8 is greater. This is negative, this is positive. Yeah, so positive one is always greater, whether it is a regular number, a whole number, or a natural number, or it is a fraction. So minus 3 by 4 is lesser and 1/4 is bigger. Okay, so we are done with these simple things. Let me come with this. This is a proper fraction, and not just proper fraction, it's a like fraction. Okay, so if it is a like fraction, then now we have to, first we saw it's a like fraction because the denominator is same. Now look at the minus 5 and the minus 4. So minus 5 is to the left of minus 4 in the number line, that is smaller than minus 4. Therefore minus 5 by 7 is also less than minus 4 by 7. Okay, and now we'll come to this. This is the toughest. Now why is it the toughest? Because this is unlike fractions, and that too both are negative. Now you really can't understand which is bigger, which is smaller. So what to do? Okay, so here we'll have to, there is one method, people do cross multiply. Okay, I have seen many people cross multiplying. They make a minus 28 and minus 24. Okay, and they say that is bigger, minus 24 is bigger, this is lesser. Okay, by cross multiplying. But I actually don't approve of this method just like that. Why? Because I don't think the students understand why they are using it. They just use it. It's an excellent method for MCQs. But then if you have to write steps, you really don't know. Will anybody tell me why exactly do we cross multiply? What's the point behind it? How do we know it? Of course it is a method and it comes correct every time. But then why do we do it? Okay, we don't know. We don't know the logic behind it. That is why what I am saying is, whenever you get like this a sum, you better go for an LCM method and find it. So LCM of 3 and 7 is a 21. So what I will do is, I'll convert this also to 21. Just now we did this, and this also to minus 28. Here minus 8 by 7 into 3 into 3. Minus 24 by 21. Yes, minus 24 by 21, minus 28 by 21. Okay, so now which is bigger? Now it is just like the other sum which had the same denominator. Now minus 24 is definitely, minus 24 is definitely bigger than minus 28. So this is how we are going to write. But then this is not the question what they asked. They never asked us this question. Okay, so what we are going to do is, we are going to reduce it again and give minus 4 by 3 is lesser than, okay, minus 8 by 7. So this is the method by which we understand. So these are, by seeing plus minus you will manage very well. The tough one is little bit tough here. And what happens in a hurry, you forget to put the, you forget to understand, okay, you see the 28, you see the 24 and you put the sign otherwise. Okay, you shouldn't do that, because negative numbers, the bigger they get, the more they are to the left of the number line. Okay. Okay, so what we'll do is, we'll wind up here today in this video. Okay, and then we'll continue with the chapter in the next video. I shall be starting from where I stopped today, that is in rational numbers only from the very next sum. In the first exercise only I shall be doing. So you can watch the video serially, you'll get a very good idea of the chapter. And once I do that, since I'm picking up every main, so you can go along with me and do all the sums of the mains one by one. Okay, so you can do the full exercise. I'm not doing the full exercise, okay, because that's not possible sometimes. Okay, so that is it for today. If you have liked the video, do not forget to like, share and subscribe. Also, it motivates me a lot to get comments from you. If you write comments, it really makes me very happy. So please write a comment, and also you can share the video with people whom you think will benefit from this, okay, from these videos. Okay, so that's it for today. Bye then.